Let us understand how to join data frames using Pandas. Let's run this Python notebook which will get us orders as well as order items data frame. Let us actually run these to actually preview the data. You can see the output here. Orders have 4 attributes: order ID, date, customer ID, and status. Order items have 6 attributes: item ID, item order ID, item product ID, quantity, subtotal, and product price. Also, data frames contain the index. In this case, these are the indexes which are generated implicitly when the data frame is created. That being said, now we'll be joining these two data frames using order ID from orders and order item order ID from order items. Let's look at the help on join using one data frame. In this case, I am using orders. Then I can say dot join then question mark to get the help. You can see that join takes several arguments. The first one is the other data frame using which you want to join the data frames, and then on to specify the fields. You can see here on can be string or list of strings or array like to actually specify a particular column name using which we want to join the data. However, the column name should be same in both the datasets or data frames, then only it will work. You can also skip this. If you actually set the index for both the data frames, join will happen based on that index. By default, the join will be left. If you want to change that behavior, you just have to use this keyword argument called as how. You can pass the arguments such as inner, outer, right, etc. Again, when you say outer, it is nothing but left only. Also, you can sort the output by saying sort equal to true using the join key. By default, it will not be sorted using join key. If you want, you can join the data using sort equal to true. Now let's scroll down here. Let's use the join without any arguments. For that, we need to set the index with the appropriate field. If you recollect the orders and order items output here, orders have these 4 fields and order items have these 6 fields. To join these two, we need to ensure that the join key is the index. So for orders, order ID should be the index. For order items, order item order ID should be the index. You can join these two, but it will actually join using the default index, which is not correct. You need to make sure that new data frames are created with the appropriate indexes before joining. So that is what we are doing here. When we say orders.setIndex of order ID, now order ID have become the index. The other fields are intact. Same is the case with order items. We made order item order ID as the index, and we kept other fields as intact. Now using this, we can say orders.setIndex of order ID join order items.setIndex. If you want, you can also assign these two different objects and we can use those objects directly. But in this case, I am joining directly using SetIndex Output on both the data frames. Now it will take care of the join, and you can see that it have returned 183,650 rows. If you look at the output, there are some records where it is projecting as null values for those where there are no entries in order items. If you look at these attributes, these 3 are from orders, these 5 are from order items, and the index is nothing but the join key only, which is nothing but order ID. In orders, it is represented as order ID. In order items, it is represented as order item order ID. Now, if you want to change this behavior and if you want to get this index as regular column, you can do so by using this approach, which we'll be seeing in a moment. But instead of performing outer join and get all the rows from the first table along with those rows which are there in the second table or data frame, plus those doesn't exist in the second data frame, we can change it to inner. So the default is it will try to get all the records which satisfy the join condition, and also those orders for which there are no corresponding order items. Example is nothing but this one. If you want to skip these records, you can say how equal to inner like this. Now if you look at the output, if you look at the number of records, it actually say 172,198, whereas with outer it is 183,650. So inner is the one which will actually give us only those records which satisfy the join condition. If you say left or right, it will try to get all the records which satisfy the join condition plus those records which are there in one data frame but not in other. Now, if you want to specify the index name as order ID, this is how you can take care. You can say reset index. If you say reset index, this is how the output will be. It will generate a column by name index and it will actually reset the join key as column index. Now, if you want to give alias to it, one of the way to generate the alias is using this approach. Let me delete this and add it to another cell. You should be able to use rename function and specify columns by passing a dict to it with the original name along with the custom name which you want to specify for the index here. So you can see now the index have become order ID, whereas earlier it is index. So this is how you should be able to get the field names the way you want them to be. Now let's perform few tasks to get comfort level with respect to joins. The first one is compute daily revenue using orders.orderdate and orderitems.orderitem subtotal, considering only complete and closed orders. Here are the steps to join orders and order items and get daily revenue. First, we need to create data frames for both orders and order items using data in files. By running the notebook, we have already taken care of that. Then we have to filter for orders which are either in complete or closed status. Then we have to set the join index for both the data frames. Then we have to join both the data frames using inner. Then we should be able to group the join results using order date and get daily revenue by using sum on top of order item subtotal. Let's go through one by one here. We can either use query or this approach to filter for complete or closed orders. Once you filter the data, you can actually set the index to order ID on top of this filtered orders and then join with order items with order item already at the index using inner join. Then we have to use group by to group the data by date, then fetch order item subtotal and apply sum on top of it. So these are all covered as part of the aggregation as part of the previous topics. Go and look into those if you don't understand and come back to this. So this is not just join but end-to-end solution for a problem like compute daily revenue using orders as well as order items datasets. Then finally we are trying to rename the columns such as sum to revenue, and you can see the output here. So we got the revenue for each date. This is the revenue. Okay, now let's perform another task, which is nothing but to get all the orders for which there are no corresponding order items. We can use default join to get orders without corresponding order items. In this case, we can say orders.setIndex order ID, where order ID will become the index for our orders data frame. Then join with order items.setIndex order item order ID. Then it will actually give us all the records which satisfy join condition plus those records which are there in orders but not order items. However, in this case, we are interested only in those records where there are no entries in order items. If you look at the output of this join, this is how it looked like. In this case, if you look at order ID 3, order item ID is NAN. Same is the case with all the other attributes within order items, which means we don't want the rest of the rows. We are interested only in those rows where there are no corresponding entries in order items. For that purpose, either we can use query like this and we can say order item ID dot is_na. Then it will only return those rows where order item ID is null. You can also use the other approach, but it will be a bit cumbersome. I like this approach than the other approach. So you can say orders.setIndex blah blah blah, and then you can say order item ID dot is_na like this. Okay, the reason why it is failing is because of the dot here. We have to remove the dot. Now I can actually go here and run this. You can see it is returning true or false. It's better to assign this to a variable. So let's say orders joined here, orders underscore joined equal to, let me remove this. Now orders underscore joined is a data frame which contain all the results which satisfy the join condition plus those records which are in orders but not in order items. Now we can say orders underscore joined, then paste it and you can see true or falses. Now I can say orders underscore joined and then in square brackets I can actually pass this and we should be able to see the records which satisfy this condition. So we are only getting those orders where there are no corresponding order items. There are 11,452 of them. So using either of the approach, we got the same results. Now let's perform another task to compute daily product revenue using orders order date as well as order items order item product ID and order items order subtotal, considering only complete and closed orders. So for each day, for each product, we want to compute revenue using this field. Once again, we can filter either by using query or this approach. In this case, I am using this data frame. I am joining both using inner, because we are not interested in those records where we have entries in orders but not in order items. Now once the join is done, let's see the output here. We have all the fields which we are interested in, such as the date, product ID and subtotal in this join results. We can apply group by and pass date as well as product ID as keys and then fetch order item subtotal like this. So this will take care of getting the grouped data frame. And if you want to preview the data, you can preview by saying list of, and then you can say of column 3. Let's preview only 3 records. You can see here. So for date 2013 July 25th and product ID 24, there is only one record, which is nothing but this one. For all the 3, there are only 1 records. There might be other products where they are sold more than once. Let's say column 10 here and see. Yeah, if you look at this, for product ID 191 on 2013 July 25th, we have these many items. Now, as we got the order item subtotal grouped based on date and product ID, we should be able to use the ag function. Using ag functions, we can actually specify sum like this, and it will give us the revenue for each date for each product ID. You can see the output here. However, when we use group by like this, you can see that order date is not repeated. If you do not like this representation, if you want to have this information as regular columns, you can just use the reset index and the output will be as per your expectation. So in this case, we have date, product ID and revenue displayed as we want. This is how you should be able to perform the join operations along with group by to actually get the aggregated results based on the join results. The emphasis is primarily on join. However, as we have covered almost all the other transformations, if you are able to understand these examples, you will be more comfortable with data frames. If you are not comfortable with these examples, then you have to go back, understand how the aggregations are done, how the filtering is done. Then you have to come here. Then even joins will make sense and you should be able to come up with the solution for your problem statement, combining all these discrete steps dealing with your data. Filtering, aggregations as well as joins. When it comes to the pipelines, typically we take care of the filtering first and then sorting last. Join and aggregations, we typically have to understand the data and determine which should be done first and which should be done next. And based upon our understanding related to data, we will take care of coming up with the solution. So that being said, so far we have seen almost all the aspects of data processing with respect to data frames using Pandas. Make sure you are comfortable with all these aspects. Reading the data from files into data frames, processing using several APIs, and writing the data frames into files. This actually take care of complete lifecycle of your data engineering or data processing using Pandas library with Python as programming language, which is very, very important not only for data engineering applications, but also for mobile as well as web applications.